For this first question, we're going to be talking about what part of the body is responsible for maintaining your body temperature. You should know that the hypothalamus, which is an area of the brain located kind of in the middle on the underside of the brain, is the region of the brain that's responsible for regulating an individual's body temperature. The hypothalamus is divided into two regions. We have the anterior hypothalamus, which is more towards the front, and the posterior hypothalamus, which is more towards the back. You should know that the anterior hypothalamus is responsible for responding to increases in core temperature, whereas the posterior hypothalamus is responsible for responding to decreases in core temperature. So let's talk really quickly about how this works. Beginning with the anterior hypothalamus, you should know that when the body temperature goes up, that increase in body temperature will get detected by thermoreceptors that are located in various areas of the body. When these thermoreceptors detect the stimulus, they will then send information about the change that they're experiencing or the change that they're detecting to the hypothalamus, and that hypothalamus will integrate the information that it's receiving and start to initiate an effect. It's going to send information to two types of tissue. It's going to send information to the smooth muscles that are surrounding the blood vessels just under the skin, and the information that it sends in that direction is going to lead to dilation of the blood vessels just under the skin, and that's going to cause an increase in the blood flow to the skin. The reason that this is done is because when blood is flowing just under the skin, the heat that's contained within that blood is able to very easily leave the body and go to the environment around it if the environment is cold enough. The other area that gets information from the hypothalamus is your sweat glands. So when your body temperature gets too high, the hypothalamus is going to cause you to start sweating. And sweating is another way that we can lose heat from the body. So hopefully with sufficient vasodilation under the skin and sufficient sweating, we can then bring the body temperature back down to hopefully restore homeostasis. On the flip side of things, if the body temperature detects that you are getting too cold, thermoreceptors that are again located throughout the body will detect that change and send information to the posterior region of the hypothalamus. When the posterior region of the hypothalamus gets that information, it will integrate it with all the other information that it's receiving and send information to various types of tissues. One of these tissues are your skeletal muscles. So when the posterior hypothalamus is informed that you are too cold, it will start to tell your skeletal muscles to contract and relax very quickly, causing shivering. The reason that we try to shiver when we're cold is because the act of shivering is going to cause your body to produce heat, and you also are going to have to produce ATP in order to sustain shivering, and the process of producing ATP will also produce heat as a byproduct, so you kind of get a double whammy of heat production by inducing shivering. Another change that's going to happen in response to the activation of the posterior hypothalamus is cutaneous vasoconstriction. So what this means is that the blood vessels that deliver blood to the area just under the skin are going to constrict, and when they narrow, that's going to make it harder for blood to flow through the skin, which means that it's more likely to stay in the core, and that's going to help you stay warm. And finally, when the posterior hypothalamus is sent information about you being cold, it will initiate the release of certain hormones, particularly catecholamines like epinephrine and norepinephrine and thyroxine. And so the reason that these hormones are released is because they can have an effect on your metabolic rate. So when these hormones are released, metabolic rate goes up, and you will start to produce heat as a byproduct of metabolism.
The idea here is that if you increase the production of heat by the body through shivering and a hormone-induced increase in metabolic rate, while simultaneously minimizing the heat lost due to the transfer of heat from your blood just under the skin to the air around you, you will hopefully bring up your body temperature enough to restore homeostasis.